I've seen 3, 2, 1, 3 weeks. All right. Okay. So here we go. It's Halloween. So look at my shirt. Yay. Okay. Get to enjoy it, I guess. Go ahead and write that down. It's fine. Okay, but actually, input say it. We're going to do some graphing today. And are pretty good examples. I'm not going to be able to get through all of what they're asking to do here just because of time, and I don't think we need to redundancy. The sheet that you picked up, though, it is a book assignment, but then one of the two teachers, I think maybe Gray, made a corresponding sheet to fill in those parts. Right. So if you look at the calendar, I got to be careful here. That's not ours. That's ours. Textbook. There it is again. But then that sheet that you have in front of you, you can use as like where the answers go. So yeah. All right. So some things to talk about first, though. Yeah, growth and decay. So we got all that stuff. We'll talk about all these terms here. But looking at yesterday, I actually did not realize that they constructed this way. Didn't you invest $1, right? And it was at 100% interest, right? Oh, yeah, sign up for that account right away. So then you'll have $2 at the end of the year if it was just tacked on at the end of the year. But then the whole thing I went over about compounding. When you get compounded, well, semi-annually, that means every 6 months. Well, it is a little bit more when you plug in 2 in for n. And then you're supposed to, hopefully you didn't write all this column out. That's kind of annoying. But hopefully you figured out what it meant to be daily. We do have to pick a normal year. I guess if you're real technical, it'd be 365 and a quarter, right? If you average it out through a 4-year span. But then all the rest of these would be affected. Hourly, every minute, every second. And what you're approaching, actually, because they picked investing $1 over 1 year, is a very, very special number. What's a special number in, I don't know what that, I'm not filling that in. What's a special number in geometry? Pi, right? You know about pi. What's pi? What's the first thing you say? 3.14. All right, and I'm going to tell you a boring story. I have a book if you want to borrow it. It's called The History of Pi. Anyone want to borrow it first? Raise your hand. It's a real thrilling read. All right, but I remember in the beginning of it, and I feel like Greece gets too much, like Pythagoras and all that. They get way too much credit. There's many, many, many other civilizations that found out, like discovered what pi was before the Greeks even did. So I used to have posters way back when I first started teaching history of math in Africa, Greece, like all the different Arab. Oh my gosh, the Arab countries. Way much algebra is an Arabic word, actually, or it comes from an Arabic word. But anyway, what they used to do, I remember reading this in the book, they'd stick a stake in the ground, tie a rope to it, but a rope that wouldn't wrap around it, like just with a loop around it, and then pull the rope till it was tethered, boom, go in the ground and mark the ground and walk around. They'd make a circle. They would know the measurement of the rope, and then they would be able to measure how far they walked around until they completed the circle. And then honestly, where pi comes from is from the circumference formula. C equals pi over, d pi. Well, actually that means pi comes from circumference divided by diameter. I couldn't think of the D word. So they literally had the diameter, that length, 2 ropes across, from the center to both ends of the circle. And they actually counted out the distance that they walked around. And from there, they got some sort of estimation. Now, back in the ancient times, I don't know if they had decimals. They first had fractions. They, throughout the centuries, got better and better and better approximations of what that number is. So it literally is where it comes from. Where does E come from? I'm going to show you. It actually is related to that thing you just did. If you wanted to play along with your calculator, I don't know why I hit that first. I actually did this in before 4th hour, but I unfortunately have this shown already. So I'm going to go back to show you what my progression is. I knew this. I actually read this back in the 90s in my pre-calc book that I taught out of at Providence. And I read E comes from this expression, 1 plus 1 over x raised to the x. But then what is x? It's an unknown. So what I did is let's skip this first one. That's a random x value that's plugged in my calculator already. I plugged in 2 for x. How do I do that? 2 store x. So all I'm doing is evaluating that expression when x equals 2. And I got nothing real special here. Press enter. Oh, I didn't mean to do that. Sorry, I didn't mean to press enter. This is bad for the video. Bad for the video. I just wanted to show you what I got when I did that. Here it is. Okay, so I pressed enter before 4th hour. 2.25. Okay. Then I put in 100 for x, and then I retype this expression. So 100 for x, nothing happens. Type that expression again, and then I got 2.70. Okay, great. And then I plugged in 1,000,000 for x. I typed that expression again. What I'm doing is I'm approaching a large number inputted for x. And then I get this, what you got at the end of your little progression of that money example, $1 invested for almost an infinite amount of times of compounding. You know, all those, every second, which how many seconds are there in a year? It's a lot. Okay, so that's why you're getting that number, you're approaching that. I'll show you something interesting. I think the calculator shut down because look at what I evaluated for, like, I don't know how many, I did 15 zeros. I don't know what happened. That's a calculator, I quit. I can't evaluate that. So I went to, I think, 1 trillion, and then it became 2.71828. I know those are at least the first 5 decimal places of what E is. And now that's a new important number that gets its own letter, just like the number pi gets its own letter. Okay. Similarly, the symbol E is used to represent the constant blah, 2.718281. I believe that's what I came close to having on that last one that I showed you. It is definitely for decay and actually growth in physics and calculus. It actually has a lot of applications. Input, say it. So you should know then that at least the graph has this shape for y equals e to the x. Because it's right around y equals 2 to the x, y equals 3 to the x. It's like in between those two graphs. Because e is 2.718. And you have to have that memorized now. You got to know that number now. So still anything to the 0 power is 1, but then 1 comma e, which is around 2.78. Do the best you can for 2 comma 2.718 squared is lower than 3 squared, which is 9, and higher than 2 squared, which is 4. All right, so I don't know. Do the best you can with that one as far as sketching. Then 1 over e is like almost 1/3. You're not going to have to show that specifically. So you should be able to graph e. Just graph 3 to the x instead of e to the x, and you're close enough. Okay? All right, and as a matter of fact, that's what we got. All right, for time purposes, I'm only going to fill out this chart for this one. The other one, I'll probably just verbalize it. And I will tell you what I'm going to have you responsible for. I really hope the other teachers are very similar. If you're left on your own for graphing, then I at least want to see 3 points, because 3 should be enough. The first point should be the 0 exponent point. That's why I highlighted this middle. Big yawn back there. All right, what's 3 to the 0 power? 1. You won't yawn if you answer the questions. You'll wake yourself. 3 to the first is 1. What's 1 times 2? 2. Okay, I do have an axis here. So wrong. I already did the first one wrong. 0 comma 2. Okay, very far away here. This is why we have these obnoxious grids. I'm not going to use them though. You really want to count the points, go for it. Bless you. All right, and then 1. 3 to the first is 3. 3 times 2 is 6. So 1 comma 2 4 6. This should be enough to say what's going to happen as I plug in 2, 3, 4. What's going to happen? It's going to take off. All right, 2 comma 3 squared is 9, 18. Do you feel like counting 18 blocks? I don't. And then 3 to the third is 27. 27 times 2 is 50. Do you want to count 50? I don't even think there are 54 here. All right, so here's what we're going to do. We're going to say, all right, we get it. We get it. Shoo, this is taken off. That's what that told me. That's why those first two are good enough for me. Then the next one, -1, 3 to the negative first is 1/3. If you don't know that, 1/3 times 2 is 2/3. No passive aggressive comments right now. Should be, though. That should be enough to say, okay, this is where we start getting this. Oh, I missed. Sorry. I didn't see where I wrote that. 2/3. We should understand this. Okay, this is 3 to the negative second, which is 1/9. 1/9 times 2 is 2/9. Okay, I get it. Then this is 2/27. These points are getting smaller. Okay, these are never going to be 0. So right away, I have a horizontal asymptote at y equals 0. And that always happens on a y equals a times b to the x scenario. All right, let's fill in our parts. Domain. Oops, that's going to be an infinity. I don't know why I put 0 there. I think I was thinking about range, which is 0 to infinity. Come on, as x goes to infinity, where's y going? Fifth hour ain't saying jack squat. You guys stink. All right. What's as x goes to negative infinity, where does y go? Oh, they don't like insults. There are some people answering now. See, insults work. All right, anyway, he can't do that. I think I just did. All right, is this growth or decay? Growth, that's easy. Horizontal asymptote, y equals 0. All right, and then, okay, ARC. What's AROC stand for? Average rate of change. I'm only going to do one of them. It's actually very easy. But the average rate of changes from 0 to 1 is basically just the slope of this line. Okay, and that we've been doing that all year long. As a matter of fact, of the 4 written questions on the AP exam when we were practicing for them, I felt like 3 out of 4 of them had a part that said, what's the average rate of change of? But they were all just different functions. So they're obsessed with this idea, obsessed. And actually, I could just do this. 1, 2, 3, 4 over 1. That's a slope of 4 over 1. So it's 4, right? It's very simple. Or I could get those inputs, I can get the input-output points and then actually find the slope and calculate it. I think it was 1, 6, right? 6 minus 2 is 4. 1 minus 0 is 1. 4 over 1. 4. Same thing. Do I have to find this one? Do you get it? Can we move on? All right. All right. What's the average rate of change doing, increasing or decreasing? Which one is it? Y. What is the graph? Anyone? Concave up. So in the previous hour, I wrote a sentence over here that this was increasing at an increasing rate, right? Remember that idea too? So this graph is increasing at an increasing rate. Okay? So just make sure you understand that. Okay, I'm not going to fill out all that stuff for this one. We're just going to input say it's. And then you know what the input outputs you really need are just these. Because my 0 exponent is 0. When I plug in 0, I get to the 0 power. We'll see how this changes on one specific question. So 1/3 of the 0 is still 1. 1 times 3 is 3. So I have 0, 3. 1, 2, 3. 1, all right. 1/3 to the first is 1/3. 1/3 times 3 is 1. Is that enough to really show that asymptotic behavior? If you really understand things, yes. But if you're a little fuzzy, then plug in 2. 1/3 to the second is 1/9. 1/9 of 3 is 1/3. Okay, there's our fractions that are going to approach 0. Very easy. And then -2, -1. Sorry, I know I keep skipping that. The yellow confused me. 1/3 to the negative first is 3. You should be able to do what I'm doing. 3 times 3 is 9. Okay, that already got obnoxiously big. 2, 3, 4, 5, 6, 7, 8, 9. And I can think, I hope I counted 9. I may have counted 8. I don't care. Or I couldn't. Anyone? Care less. And then I plug in -2. That becomes 9 times 3, which is 27. Good Lord. Yeah, these are starting to get huge. And I don't want to count to 27. Okay, so yet again, we got y equals 0. Increasing or decreasing? Decreasing. At a what kind of rate? Increasing or decreasing? Here's why. This slope of this tangent line, a guess might be like negative 20. It's really steep. But then this one might be like negative 5. This one might be negative 1. This one might be negative 1/2. What are those numbers doing as I move left to right? Going up or going down? They're actually going up. It's hard to think negatively. They're actually going up in value. I had a really hard time with this when I first learned this 2 summers ago. How's that an increasing rate? All right. And that's how we had to think. All right. Just what I told you about E. Here's at least what we should be able to do. I wish there was more questions like this. Yeah, I gotta, I saved trees again, right? It's okay, right? You can see enough. Some people just give me a dirty look. I want more papers. Kill those trees. How's that gum? Good? What's e to the 0 power, everyone? What's e to the 0 power? 1 times negative 2, though? Okay, so you see what that negative 2 did? It flipped it. It threw it over. I got to ask somebody about this. I got to ask my whole set of group of people. So I got a really big problem with this. What I'm worried about is increasing, decreasing. I know what it should be, but then the AP people, they always mess with their mind. What's e to the first? You should know that. What is it? 2.718. But then times negative 2. Okay, so let's just say it's negative 2e. And then know that that's okay. What's negative 2 times 3? Negative 6. So a 1 comma 1, 2, 3, 4, 5. Wait a minute. I know what 2.8 is doubled. That's 5.6. Is 28 times 2. So 5.6 just doesn't really matter. You're before negative 6. That's what really the key is. And then you should know that this is negative 2e squared. Do I have that right? Yeah. And then that's just e squared is not quite 9 times negative 2 is not quite negative 18. But what it is getting crazily negative. So I already know that this is the behavior happening. So even though I don't have a calculator, you can still make a sketch. Don't panic. All right. And then negative 1, e to the negative first is 1 over e. So this is negative 2 over e. You should know that that's 2.718. So negative 2 over like 3 is what it's close to. That's negative 2/3 is what it's close to, which is right here. All right. So all these things should be in your head, and it's not hard. Not hard at all, as long as you know what E is, 2.718. All right. And then the next one's negative 2 over E squared. This is all you could write without a calculator. By the way, E is on the calculator. I forgot to show you that. I forgot to do that in the other class. Watch. Okay, so that's what E is. I made a mistake here. That was a mistake. So 2.718. Here it is. Second, E, press enter. Look at that. 2.718281. Holy crap. When I plugged in, I didn't expect that. Those are exact to all those decimal places. When I plugged in that one with 12 zeros. No one else is impressed with that? Yeah. Okay. All right, anyway, that's where E is on the case. Oh, fine, great. All real numbers, range, fine. We'll write that because some people screw this up. You got to write negative infinity to 0 for the range. All right, limits, x goes to infinity, it's negative infinity. Y goes to negative infinity, that's 0. And then you could do increasing or decreasing. This is what I don't like. You ready? What would you think? Increasing or decreasing? What is it? That's what I think. But then the AP people, they like scramble in people's brains. And then we thought of it this way. What's the national debt? We're going to get political right now. Right? You can actually play this later. Just get this excerpt. What's the national debt doing right now? Growing at a horrific pace under this last regime. All right? That's why my groceries cost triple. All right? Sorry. So it's growing, but what is it? What kind of number is it? It's severely what? What kind of number? Negative. So then The people in AP said this was an increasing graph. I'm like, what? Now you're really jacking around my head here because what's the graph doing in a parabola? What's this part doing right here? It's decreasing, and it's always been decreasing. So I fundamentally object to that idea. That should be decreasing. Otherwise, math is just turned in. Now we're just in bizarre world, all right, and things just don't make sense anymore. But I think that's what they were trying to, make you think about that. I'm gonna try to avoid those kind of questions when we get a flip over the x-axis and that. But we at least know at what kind of rate is it doing? Is it increasing or decreasing? What kind of rates? What's the rate of change doing? That's a no doubter. Okay, it's decreasing because it's getting more negative, those slopes of the tangent line. What time, how much time do I have left? I'm just gonna do input, say it. We don't have time for all this. And I don't like it for you either when you have to write all the things out. Look at your homework sheet, by the way. Did I tell this with you? Your homework is one of these again. It's one of these, a textbook, and you got to open it. I think I killed the numbers. I think I did. Oh no, the homework, the sets on this homework sheet that you have in your hand, and everything you need to fill in is on the sheet. So you don't have to write limit statements. You just fill in the answer, right? Aren't limit statements given to you? Because isn't that annoying? You have to write it over and over and over again. Yeah, I don't think we should have to do that all the time. Oh, okay. All right. All right. So input, say it. That's all we're going to do. And we're going to do the Samuelis way. How many points do I want? 3. What's the first point? Okay, nothing really special happens still on this one. I will say this, though. 2 to the negative x is equal to, you can actually make this like this. This is a rule of exponents. I could separate that like that because what are you supposed to do with these exponents then? Multiply them. We do have that coming up later, how you can write things in different formats. And then what's 2 to the negative first? 1/2. This is equivalent to this graph. So it'll be a decay. All right. I think that's what they're really saying. Even if it's flipped, the base still dictates if it's increasing or decreasing. And I believe the national debt is decreasing exponentially. And it's at a very steep part of that exponential curve. It's very sad. 0. 2 to the negative 0, 2 to the, that's 1. 1 minus 4 is negative 3. Okay, so this is why they did this too. This is nice. They allowed you to put your x-axis wherever you wanted. I don't think I'm going to get some crazy numbers here. What did I write there? Is that a 3? Good Lord. Is that negative 3? Yes, Mr. Samuelis. I think I went too high, but you know what? I'm going to be fine. Because 0 comma negative 3, what does this mean? Oh, does this mean this is flipped over the x-axis? No, there's a minus 4. That means the asymptote got pulled down 4. So this didn't get flipped. It's just shifted down 4. So that's why the asymptote's at y equals negative 4. All right, and then when I plug in 1 and negative 1, just right around those, I should get enough behavior. 1 is weird. When I plug in 1, it's 2 to the negative first. There, I got it. It's 1/2. 1/2 minus 4 is negative 3.5. So at 1 comma, that's where I'm approaching that asymptote. That should be enough. But if you want to plug in 2, that's 1/4 minus 4, which is negative 3.75, and so on and so on and so forth. I plug in negative 1, that cancels that negative. It's 2 minus 4, which is negative 2. Is that enough to show that this is growing? Fine. Plug in negative 2 and negative 3 and see how this turns into strong exponents on 2. Like negative 3. 2 to the negative 3 is 2 to the third, which is 8. 8 minus 4 is 4. So at 1, 2, 3, 1, 2, 3, 4, that's pretty good to show that this is starting to take off on the left. Right? That's what I mean about all that. And then you can fill out all the other stuff, right? You're okay with that. We just got to know how to graph. Input, say it. What is the, you should have known this from last year. Those that had me last year, this is what I told you to do on quadratics when it was x plus 2 squared on the inside and then plus 4 on the outside. What did you put in the chart? What number did you start with? What number do I put there? Oh no, not 2, not 0. I have 2 students that I had last year. 1, 2, 3, -2. You don't remember that? We want the number that makes the parentheses 0. So what I was trying to get you to understand is we graphed quadratics about a year and a month ago. And if it was like this, your first chart value was -2 because that's where the vertex was located. Well, -2 is the what exponent? What happens to the exponent? It becomes what? 0. That's the point that's really close to the asymptote. It's the most important point. -2 plus 2 is 0. 3 to the 0 is 1. 1 plus 4 is 5. We might get some large output values here, so I'll go somewhere around here and go 0. Wrong. -2, comma 1, 2, 3, 4, 5. Wait. Oh, okay, I get it. 4 up, 1, 2, 3, 4. I should have an asymptote here then. So what I'm saying is that's where the 0, comma 1 point moved. This is 2 left and 4 up. You got to recognize this as transformations. You had that last year. Some people complained about transformations this year. It's because we did it last year. We did it a lot. We did it with every single thing we graphed last year. Quadratics, square roots, cubics, maybe a little bit with circles when we went and there was some shifting going on with circles, hyperbolas, parabolas, a little bit, but somewhat. -3 plus 2 is -1. 3 to the negative first is 1/3. 4 and 1/3. That's enough. -3, 1, 1, 2, 3, 4 and 1/3 is barely above 4. That's enough. I know that's what's happening there. It's getting to that asymptote. Then -1 plus 2 is 1. 3 to the first is 3. Plus 4 is 7. That should be enough to know 1, 2, 3 more. Okay. And then if I had to find the y-intercept, sometimes they ask this. The y-intercept is 0, comma. What's 3 squared, everyone? 9 plus 4, 13. It's somewhere up here. I don't even feel like counting right now because I got my promise that I'm going to get to those questions at the end that I didn't with them. Just one more thing on this one. Input, say it. What am I going to input first? See if you got this. What am I going to input first? 0 is right. There is no right left shift. What's 0 divided by 2? 0. What's 5 to the 0? What's 1 minus 1? Okay, hold on a minute. What's going on here? I got 0, 0. That's weird. So 0, 0. Oh, where's my asymptote? Y equals 1 or -1? 1. Okay, so what we have here is a flippage. We have a flip because it's -5. It's minus the base. So it is 1 up, but then it's flipped because the base has a negative in front of it. The base is not negative. No way. PEMDAS. Hey, some of you guys screwed up PEMDAS on my Halloween shirt, right? Okay, anyway. All right, so then I plug in -1 and 1. Which one's wrong? What am I going to plug in? I don't want things to be hard. I want them to be easy. 2 and -2. This is no calculator. You got to be able to function without it. What's 2 divided by 2? What's 5 to the first? Tough questions. 1 minus 5 is -4. So that's enough for me. 1, 2, comma, 1, 2, 3, 4. Okay, I get it. This was supposed to be growth with a base of 5, but then it got flipped. And then -2, that's 5 to the negative first, which is 1/5. 1 minus 4, 5/5 minus 1/5 is 4/5. That's enough to, yeah, so that flipped over to this side. 4/5 is already close to 1. So that's enough. This is why I think 3 points is sufficient. What time do I have? I have 3 minutes again. Guess what? You guys are going to have to watch a video. So I'm going to do notes through my lunch. I'm going to starve because I'm doing notes for you guys. I could probably use a little break on the food anyway. But I'm going to starve and finish these notes, but you can watch this first one, which is really easy. So 4th hour, don't come in crying that you had to watch a 5-minute video. 5th hour does as well. Hey, by the way, what's 0, 3 in this general format of an equation? Which letter is it? A. It's the initial value. So I see the initial value is 3, and then 1 comma. What's happening? 3, 12, 48, 192. What's happening? They're getting multiplied by what? 4. That was tough. Y equals 3 times 4 raised to the x. Of course, it's going to get more challenging. All right. Hey, the y-intercept is 0, comma, -1. So what letter does that represent? Yet again, A. And then actually what you do on this is do a system. So I have -1 times b. Don't do nothing. Do something. Well, they gave us this point. Input, say it. So that means -1/25 equals -1 times b raised to the -2nd. It's going to be a little weird. And then, okay, then y -5 equals, that was kind of easy, actually. I don't even why they know why they gave us this point, because it's -1 times b to the first, right? This is actually absolutely useless, because what is the b value? What is the b value? I'm sorry, it's 5. All right, so b equals 5. I wish this was better, like this was 2 comma or 7 comma. Then you would have had to do a system and then solve for b. But they gave me the 1 comma point. I already know what the a value is, so I already know what b is. One thing I want to check, though, I might feel a little guilty, like not guilty, like suspicious. Was it that easy? Plug this point in and see if you get the output value. So I plug in -2. What's 5 to the -2? 1/25, and then you multiply it by what? -1. So I wish that was not a 1. That made that question a lot easier. Okay, last one. Okay, this one's a strange one. Boy, I hope I do this right. Well, I could just cancel the video and just if I do this wrong. All right, so we got, wait a minute. The horizontal asymptote is at y equals 3. All of these, when it's y equals a times b to the x, the horizontal asymptote's at y equals 0. So what does that mean? I don't have this parent function anymore. I have this. This is moved up 3. Oh, that's rough. And then, okay, they did it again. They gave me that 0, 4 value. Okay, so that means that's a. Y equals 4 times b raised to the x plus 3 because of this information. Oh, this is easy. Input, say it. Then I just take this last point and input it for x and y, and the only thing I have left is b. So 19 is y, 4 is x, b is unknown, -2 is x, 4 is the a value. I said that wrong. I just caught myself. Plus 3. Well, that's very solvable. Subtract 3, I get 6. Well, that's convenient. 16 equals 4 times b to the -2. Divide by 4. You get b to the -2 equals 4. How do you solve this one? B to the -2 is 1 over b to the 2nd. Whatever you do to one side, say it. So I could flip the left side. That means I could flip the right side. Huh? I just blow your mind? All right, and then b equals, oh no, it could be plus or minus. So whenever that occurs, we do got a problem. It could be one of two b values because, wrong! Exponentials can never have a negative b value. Only geometric sequences. So it cannot be a negative b value. So see ya. All right, take it easy. So the answer is y equals 4, that initial value, times 1/2 my r value I found through that math that I just did, x plus 3. Okay, and then input, say it. I'm just going to plug in -2 and make sure I get 19. Discount, double check. 1/2 to the negative second is 2 to the second, which is 4. I'm getting excited. 4 times 4 is 16, plus 3 is 19. So as long as I get that point, I should be good as a discount double check. All right, well, maybe I do get to eat my lunch now. Yay. All right, I'll remain fat. Okay, have a good day.